Today in DC electrical circuits, we're going to be looking at a DC circuit simulation exercise using National Instruments MultiSim. The objective: this exercise will involve the simulation of basic series parallel DC circuits with resistors. The use of multisim will be examined as one technique to determine the circuit's currents and voltages. Under reference sections, I'm referring to Holmes Outlines, Basic Electricity, 2nd edition. As you can see, Chapter 4 is direct current series circuits, Chapter 5 is direct current parallel circuits, and Chapter 7 is Kirchhoff's laws, both as voltage and current law. If you're not familiar with them, you might want to reference these sections. Under Theory Overview, we're going to be using DC Electrical Circuits Lab number 7, Series Parallel DC Circuits, as our basis to introduce you to National Instruments MultiSim. MultiSim is an industry standard SPICE simulation and circuit design software for analog, digital, and power electronics in education and research. Now, there is a student version available of this software, and it's at their website, ni.com. So on your desktop, you're looking for an icon shown on the right, and I believe our version is MultiSim 14.1. So under Equipment, write down the version number of MultiSim that you're using. Under the schematics, we have two schematics we're going to be doing today, Figure S1 and Figure S2. So I just wanted to jump to the output that we're going to generate today. This is DC Circuit Simulation S1, and it's a typical CAD drawing. In the bottom right hand corner we have a title block that gives us the title of the page, any relevant information to go with it, like who it's designed by, who it was checked by, the document numbers, the dates, and the sheet size and the revision. So all that kind of stuff goes in your title block. In the center of the page is our schematic, and you can see on here we have a power supply and a few resistors, and we're going to take a voltage and current measurements at different points in our circuit, and we're going to put a title on our page, so just so it stands out so that we know what this page is all about. So that's page number 1. Now on page number 2, you can see we still have a title block. So all CAD drawings will have title blocks in there, usually in the bottom right hand corner, so everybody knows where to look for it. You can see we have our second circuit wired up here, and I am taking a couple of current readings, and these of course are the voltage readings at the different points on the circuit. And I'm taking the voltage from the first page, and of course I have my title for the second page. So the procedure has 10 steps to it, and you can see that it is fairly wordy. It's kind of hard to describe how to click on things on your screen and different menus and such, but I've tried my best to put them in under the procedure, so I'm going to let you read the procedure rather than me read it to you. So as you can see, there are actually 5 data tables for you to fill in. You're not to be doing any calculations. These are just measurements that we're going to take from MultiSim. So under Procedure, step number 1, we're going to open MultiSim by double-clicking on it. So under Procedure, step number 2, we're going to go to Place, Title Block, and it's going to be v6.tv7. Say OK. Just drop it on the page. Now we have to put some data into each of these fields, so double click on your title block, and the first field is title. So we're going to put in DC circuit Okay, now we're going to go down to description, highlight whatever's in there, and put in DC. Now where it says designed by, we want your last name, followed by your first. Under document number, we want your student number. Under revision, we're just going to call this revision 1.1. Checked by will be your teacher's initials. For date, we're going to leave the ampersand D, and that'll pick up today's date. The page size, it's an A size, which is an 8.5 by 11. Approved by, that'll be your initials. And we're going to leave sheet as ampersand P of ampersand capital P. So we can click on OK, and you can see it fills in the data for us. Now we want this title block to be in the right bottom corner, right in there. It'll be hard to place it. So if you do a right click on the title block, you can see that there's the option to move to, and we can move it to the bottom right. Click anywhere on your page will deselect the title block. So the next step is to build the circuit of figure S.1. So we're going to go to Place, Component, and we want to place some resistors. So that's in Basic. And then we go down to Resistor, and it gives us a whole list of resistors that we can place in there. So the first resistor is going to be our 1K ohm resistor. So just drop it somewhere appropriate. The next resistor is the 2.2K ohm resistor. So you can scroll down with the mouse wheel, click on 2.2. And for right now, just drop it on the screen. Don't worry about its orientation. The next resistor is 4.7K. We're going to drop it on the page. And then we'll close. Now to rotate any of these components, if you right-click on it, you can see you can rotate it 90 degrees. So both of these need to be rotated 90 degrees. Now you can click on it and drag it and move it around your screen so you can place it anywhere that you feel is appropriate. The next thing that we need is the multimeter. So that's over here on the right hand side of the screen. Just click on it, and then you can drag it around and put it anywhere on the screen you like. If you double click on it, you can see it's a multimeter. We have A for amps, V for volts, and the ohm symbol to set it up as an ohm meter. So click on ohms, and then you can close it down. Now we need to connect all these together. It does not matter which one of these pins you select. So if you click on a pin, you can then drag the wire over and then down, and it just follows the cursor around the screen. So we're going to connect R3, and then you can connect R2 up to the line. At the bottom here, we can go down and connect it to our meter. Now you'll notice as I move it up and down, the entire line moves up and down. But if I do a left mouse click, it now anchors it. So every time I do a left mouse click, it will anchor the wire. I'll finish connecting R2. And then I'll bring my wire around, do a click to anchor it, and then up to the meter. Now MultiSim likes a ground to be shown on the screen when you're doing a simulation. So I'm going to go to Place, Component, and I don't want the group basics. I want sources and power sources. And here you can see I've got a ground, and that's the ground symbol. I'll click on OK, and I'll just drop it here, say close, and then I'll hook up my ground. To run the simulation, you can click on this little icon here that says Run, or you can go up to Simulate and click on Run. In the bottom portion of the screen here, it will give you any error messages. But you'll notice the meter does not display anything. You have to double click on the meter to get it to display something. So here you can see it's displaying 2.499 k ohms. So this is basically 2.5 k ohms. Don't forget to record this in table S.1. So moving on to procedure step number 4, to make any modifications to your circuit, you need to stop the simulation. You can press the stop button, or you can go to Simulate, Stop. Now we're going to close down the ohm meter, and if you click on it and press the delete key, it will take it out of your circuit. So the next thing that we're going to do is connect a power supply. So we go to Place, Component, and under the group, Sources, Power Sources, and we want DC power. And we've got a multi-cell battery symbol here that we'll be using today. So I'm going to throw that into my circuit, and then close the Select Component dialog box. I can now hook this into my circuit. Now you'll notice that the voltage is 12 volts and we want 10 volts. So if you double click on the power supply icon, we have Label, Display, Value. And the value, it says 12 volts. We want to change that to 10. And then we say OK. And now you can see we have a 10 volt supply. Now if we were to simulate this circuit all by itself, it wouldn't show us anything, so we need to put in some kind of voltage indicators. We could put in the multimeter, but then we'd have to open the meter for every single reading. So I'm going to show you how to put in some indicators. So I'm going to Place, Component, and under Group, we're going to go down and select Indicators and Voltmeter. Now you can see we have several different voltmeters we can select. We have horizontal with plus on one side and minus on the other side. We can use this to measure the voltage drop across R1. We also have H reverse, so the minus is on one side, the plus is on the other. And we have a vertical voltmeter. So this is the one we're going to use to measure the voltage at point C, or the voltage drop across R2 and R3. I'll close the dialog box. To wire it up, you just click on the wire and drag it down to one side of your resistor. The other wire we drag down to the other side of the resistor. Same with measuring the voltage at point C. Now you'll notice the voltages say 0. So unless we simulate this, we're not going to see what the voltage levels are. So you can see we have 4 volts dropped across R1 and about 6 volts at point C, or the voltage dropped across R2 and R3. Notice that the 2 add up to the 10 volts supplied. Don't forget to record these values in table S.1. Under procedure, number 5, we want to measure the current flowing in our circuit. So to modify our circuit, we have to stop the simulation. And we're going to go to Place, Component, and under Indicators, we want to place ammeters. Now we want the ammeters to be underneath the resistors. So I'm going to choose ammeter V and say OK. And I'm going to place 2 of these in my circuit. Now in order to get them in underneath the resistor, I'm going to have to move the resistor up. So all I'm doing is clicking on the resistor and sliding the mouse button up. I want to delete this connection, so I just click on it and hit delete. Or you can click on it and right click and select delete. Then I'm going to move my ammeters down underneath those resistors. Try and get them on the same horizontal grid lines so that they look neater when you print these out. Now I'm just going to connect the meters to the resistors and the meters to ground. To measure the total current, we're going to use a probe. So we can go to Place and Probe. And here you have to select which type of probe you're going to use. We're going to use the voltage and current probe. Now as you bring it into the circuit, you'll notice there is an arrow on the bottom of it. And as you move it around, the arrow will change direction. Depending on which way you're bringing it in. So this is about where we want to place it. However, you'll notice it's pointing into the power supply. So I'm just going to click on it, do a right click, and we're going to flip vertical. Rotate 90 degrees. Flip horizontal. Rotate 90 degrees. Reverse probe direction. Then when you're finally happy with it, you can see that we have more room on the right than we do on the left. So I'm just going to move my mouse cursor up to the top, highlight everything, and then move everything over so that it's more centered. Eventually you'll be happy with it, and then you can run your simulation. Now you can see we have the current running through R2, the current running through R3, and the total current and the total voltage coming out of our power supply. So these currents are to be recorded in table S.2. So under procedure, step number 6, we're going to get our circuit ready to be printed. So the first thing we're going to do is turn off the simulation. We want to place some text. So we go to Place, Text, and we're going to put it somewhere around the top center. It's going to be labeled DC. Now they want us to change the font to be Times New Roman. And they want it to be a size 32. And we want it to be bold. So click anywhere else on the screen. And now you can kind of center it on the page to where it looks best. Make sure you check the spelling because there is no spell checker in MultiSim. Now we've got a lot here being displayed on the probe. So it says to clean up the display, double click on the probe. Then under the General tab, we're going to change reference designation to IT. Then in the Parameters tab, we're going to click on Custom. Right now you can see we have a lot being displayed. So if you click on Show, it turns everything on. If you click on Show again, it turns everything off. We want to see volts DC, so click on it and it'll become yes. And we want to see current I DC. Click on it and it will become yes. Say OK. So now you can see our probe displays volts DC and I DC. So that's going to give us our total current IT. On the voltage indicator across R1, we're going to double click on it. On the Label tab, we're going to change the reference designation to VR1. On the Display tab, we're going to use component-specific visibility settings. We only want to show the reference designation. So turn off all the others and say OK. So now we don't have all the details of the meter showing underneath it. So it says VR1. We're going to do the same thing with the voltmeter across R3. The label for it is VC. And then instead of having VC on the side here, we can click on it and we can actually move it so it's above the meter. We're going to do the same thing for the ammeters. So this is going to be IR2. Put it on top. And this will be IR3. So this looks a lot nicer for when you want to print it out. So under procedure, step number 7, we want to build the circuit of figure S.2. It says to create a second page because we don't want to squeeze everything on one page. It says do not click on File, New, because this will create a brand new design. We don't want a new design. We want a new page. So we want 2 pages in our design. So I'm going to click on Cancel. We're to go instead to Place. And you can see here, we can go to Multi-Page. The page number is going to be page number 2. We'll say OK. So you can see over on this side we have design 1, number 1, and design 1, number 2. So if I click on number 1, there's our original circuit. If I click on number 2, we've got a blank page. So we're going to need a title block. So what we're going to do is we're going to go to page 1. We're going to scroll down to our title block. Left click on it. So to copy our title block over, we left click on the title block, go up to Edit and say Copy, and then go to page 2. You can do a right click, Paste, or you can do Edit, Paste. And that'll bring our title block over. Notice it automatically says sheet 2 of 2. So if you right click on it, you can move to the bottom right. And it puts it in the bottom right corner for you. Going back to page 1, make sure you haven't moved it. Put it back in the bottom right if you have. You'll notice it now says page 1 of 2. So this is a good start. Now we're going to place our components. So we're going to start by placing some resistors. So I go Place, Component, Basic, Resistor. And my first resistor is going to be a 1K ohm resistor. Don't worry about the orientation, just drop it on the page. I just want to show you that it automatically increments to R4. If you go back to page number 1, you can see we have R1, R2, R3, and then on page 2 it becomes R4. Because it's part of the same design. You cannot have 2 components with the same reference designation in the same design, so there can't be a second R4. My next resistor is 2.2K. $4.7K, and 6.8K. Now I need to rotate these. And remember to leave some space. Make sure that they line up in the same grid line. Remember to leave some space underneath because we're going to need some ammeters. Now we're going to want to connect the power supply from page 1. In order to do that, we're going to use an off-page connector. So on page 1, I'm going to go to Place, Connectors. I'm going to select the off-page connector. I'm going to connect it to the top of my power supply. I might need to move my probe around. We're supposed to label this E. So on page 2, Place, Connectors, my off-page connector. And it's going to be E. Now notice it comes up with this dialog box that says connector already exists with the same name. If you continue, a connection will be made to these other connectors. That's what we want to do, so we're going to say yes. So this connector on page 2 that says it's E is connected to this connector on page 1 that is also labeled E. Once you've labeled your meters, you can run your simulation, and you can see I'm getting my current at IR4, IR5, and at the voltage points G, F, E, and D. If you go back to page 1, you can see the probe is on the output of the power supply that feeds simulation 1, and through the off-page connector, it also feeds page 2. So the current reading here is the total current of both circuits. Don't forget to record all these readings in table S.5. So under procedure, step number 9, we're going to go Place, Text, and this is DC. And don't forget we want Times New Roman. And the size is 32, and we want it in bold. And we're trying to center this on our page. It also says to clean up the indicator displays, which we did in the previous step, so we could get our readings. So under procedure, step number 10, we want to print both pages of our design. So once you're happy with the look of both pages, we're going to go up to File, Print, Options, Print Sheet Setup, and then underneath our output options, make sure we click on Entire Design. If you have a color printer, you may want to select black and white. Most drawings are done in landscape. We want to print it 100%. You'll notice we're in inches, and we're going to have a 0.3 inch border all the way around. Then we can go to File, You can do a print preview, or you can go directly to print. Make sure that you have the right printer. We're going to print all pages and click on OK. Do not forget to save your designs every so often, because if there is a power cut, you will lose everything. So you can see I've saved mine. I went to File, Save As, and I saved my design as S1, and it's a .ms14. And as you can see, there are 5 questions for you to answer based on your simulation and observations made during this exercise. And if your instructor has assigned this as a lab, please make sure you leave your simulation running on the screen and show it to your instructor so that they can initial your lab to indicate that it is complete.